Hello, academic stars around the world. Welcome back to Caltex Academy. Today on our board, we have the shortest distance between 2 points measured on the Earth's surface via the poles and along the grid cycles. So I've drawn for you 2 cycles here. This longitude grid cycle that divides the Earth into 2 hemispheres, Eastern Hemisphere and Western Hemisphere. And I also have here the latitude at 0 degrees that divide also the Earth into 2 hemispheres, and that is the northern hemisphere and the southern hemisphere. So this point is the north, and somewhere down here we have the south. Meanwhile, this is east and this is west. And remember, these 2 great cycles lies at 0 degrees. The same to this one, we also have 0 degrees south. Meanwhile, here we have 0 degrees north. Now, in our video here, we're just looking at how to tackle such kind of questions. And in our next video, we shall look at example related to this. So let's assume somebody moves from point A, and the point A is where this longitude meets the latitude. At this point, we can say A, and where it also meets the same latitude in the other side of the Earth, saying B. So there are 2 ways in which we can move. So one of the way we can move from here is along the north, where we can move from that direction up to here. That is route number 1. And the second route is when we move either in the eastern hemisphere or in the western hemisphere. So I think the eastern looks a little bit clear. So this is another route in which somebody can move from A to B or from B to A. So you get the idea. Now, when you look at these 2 routes, you realize that one is shorter than the other one. So you can see physically that from Eastern Hemisphere or from Western Hemisphere, the distance is longer than moving from A through the North Pole to B. So now how do you calculate these 2 distances that move from A through the Eastern Hemisphere and A through the North Pole? And that is easy. What we have to do here is to make sure that we know the degree in which the latitude lies. So we can call this to be alpha in the Northern Hemisphere. And we need to subtend also this point to the center of the Earth. And of course, the center of the Earth is here. My diagram is not all that straight, but at least you get the point. We have here O. Then again, point B, let's extend it to the center of the Earth. And you also notice that our AO is the radius of the Earth, R, and OB is also the same radius of the Earth. So let us again subtend this point from 0 degrees to the center and also to the other side here. So previously we learned that this angle will be the same as the angle here and also the same angle there, because if we join this line here, there would be another center here of this small cycle. Maybe you can call it C. So you realize that at this, we have obtained a Z angle, and this angle alpha is exactly this one here. Now, the properties of Z angles, in your geometry, you learned that the angle here is the same to this angle. So the same thing, this same angle here forms that. Now, for us to get this distance A, B, we need this angle here. Now we can call that angle to be maybe theta. And how do you get theta? So simply we can get theta by adding alpha plus theta plus alpha equals to 180, because they are angles in a straight line, as you can see from here. Maybe let's call this one here to be P and Q. So PQ is a straight line, and these angles make 180 degrees. Therefore, our angle theta plus the angle alpha plus the next angle alpha must give us 180 degrees. So when you add these two alphas together, we'll get 2 alpha equals 180 degrees. So we can solve for theta, and we have 180 degrees minus 2 alpha. Now we know that OAB is a small portion called minor sector that if we extract it out, it might look like something like that, where our A is this and B would be here. Then we assume our point at the center to be somewhere here. And if we join these together, we have that. Also, we join A to the center, and our center was O. This is exactly our angle theta. And remember, this is the radius of the Earth, capital R. So for now, our main interest is to get this distance AB. Now, since it's a minor sector, we need this angle over 360 as the center degrees. So remember, our N is also somewhere here. That is the North Pole. Therefore, A, N, B, that arc is given by our angle at the center, that is theta, over 360 times the circumference of the grid cycle, which is twice pi and r. So we can go ahead and reduce by 2 to 1. By 2, we also get 180 degrees. And if we write that, let's get more space here, and we have A and B. This will give us theta over 180 degrees pi r. So that becomes the formula for us to get the shortest distance between A and B through the North Pole. So again, we need to also see how we can get the distance from A to B to compare for sure that is this shorter than the other distance AB through the Eastern Hemisphere or not. Now, what do we do in order for us to also get this? So let us draw some angle here. Now, this time we are taking this horizontal plane through the eastern part here, and we have this to be another angle. So this time, let's call this one here to be angle phi. Now, this angle phi is a straight line that is 180 degrees. So since it has divided this into two equal parts, then we'll have as half of the circumference of this minor sector here, because we have the major or the grid cycle down here. And we know also that this is a small radius r. Also, here is a small radius r with its center C here. Now, what we have to do is to get this and give it over 360 degrees from here. We also apply the same formula to get that. So let's do that down here. And we say, for us to move from A to B in the Eastern Hemisphere, we need the angle phi over 360 degrees times twice pi small r. But we know also that small r is given by capital R cosine of alpha. And alpha is the angle in which the latitude falls. Now, what we have to do here, we know our theta is a straight line that is 180 degrees. So we can make a substitution of that angle, and we have 180 degrees divided by 360 degrees. That is twice pi. And replacing small r with capital R, we'll have r cosine of angle alpha. Now you can see clearly that we can reduce this to 1, this to 2, and again by 2, 1, by 2, 1. So what are we left with here? We're just left with our AB equals our pi r cosine of alpha. So when you look at this formula we have just given here, is leading us to move from point A to B through the eastern hemisphere. Is the same like if we move through the western hemisphere. And studying it carefully, you realize that it is giving us a greater results here than here. When you look at this, we have a fraction. A fraction always can reduce a number and it becomes somehow smaller. So this becomes the formula that can give us the shortest distance that we can move from point A to point B through the North Pole than here. So stay tuned. In the next video, we're going to look at example that illustrate exactly what I've learned in this video. If you have gotten some value from this video, go ahead and like the video, share with friends. Remember, sharing is caring. So see you in that video. Peace out.